They called it a toy telescope when Private First Class Henry "Eagle-Eye" Thompson started assembling mirrors, lenses, and metal tubing he'd scavenged from destroyed vehicles around his foxhole. The Army had issued standard periscopes that were supposed to allow soldiers to observe enemy positions without exposing themselves to sniper fire, but Henry knew the regulation equipment had a fatal flaw: it could barely see 300 yards clearly, while German snipers were picking off American soldiers from distances over half a mile. Henry had grown up in the mountains of West Virginia, where his father had taught him that survival depended on seeing danger before it saw you. On October 8, 1944, in the dense forests of the Hürtgen, Henry was about to prove that a hillbilly's understanding of optics and observation could outperform millions of dollars in military research and give American forces their first clear advantage in the deadliest forest battle of World War II. What happened next would revolutionize battlefield observation, save countless American lives, and demonstrate that sometimes the most sophisticated technology is no match for practical ingenuity and a deep understanding of how vision really works. If stories like this fascinate you, make sure to hit that subscribe button. These accounts reveal how American resourcefulness and individual brilliance achieved what entire research departments couldn't accomplish. The October mist hung thick and gray between the towering pine trees of the Hürtgen forest, creating a claustrophobic atmosphere where visibility was measured in yards rather than miles. The forest was a nightmare landscape of mud, fallen trees, and concealed German positions that had turned what should have been a routine advance into a grinding battle of attrition that was costing American lives at an alarming rate. Private First Class Henry Thompson, 22 years old from Beckley, West Virginia, crouched in a foxhole that had been carved out of the German soil just 50 yards from enemy lines. Henry was a scout and forward observer for the 28th Infantry Division, responsible for spotting German movements and calling in artillery strikes on enemy positions. The problem was that spotting anything in the Hürtgen forest required exposing yourself to enemy observation, and German snipers had turned the simple act of looking over the edge of a foxhole into a death sentence. Standard Army periscopes were supposed to solve this problem by allowing soldiers to observe while remaining concealed, but the equipment had serious limitations that made it nearly useless under forest combat conditions. Henry had been using regulation periscopes for 3 weeks, and he understood their weaknesses intimately. The mirrors were too small and poorly aligned, the lenses had insufficient magnification for long-distance observation, and the entire device was built more for trench warfare than for the kind of forest fighting that characterized the Hürtgen battle. Most critically, the standard periscopes couldn't see clearly beyond 300 yards, while German positions were often located 800 to 1,200 yards away through thick forest cover. This meant that American observers couldn't detect German movements until the enemy was close enough to launch effective attacks, giving the Germans a significant tactical advantage. Henry's background made him uniquely qualified to understand and solve these problems. He had grown up in the mountains of West Virginia, where his father, Robert Thompson, had been a surveyor and amateur astronomer who had taught Henry about optics, telescopes, and the principles of long-distance observation. Robert had built his own telescopes for astronomical observation, and he had taught Henry how lenses, mirrors, and magnification worked together to extend human vision far beyond its natural limits. More importantly, Robert had taught Henry how to adapt optical principles to practical applications, using whatever materials were available to create devices that served specific purposes. Henry had used these lessons throughout his childhood for hunting and exploring in the West Virginia mountains, where the ability to spot game or hazards at long distances often meant the difference between success and failure, safety and danger. Now, facing the deadly challenges of forest warfare, Henry was ready to apply his father's teachings to a problem that was killing American soldiers every day. The inspiration that came from desperation. The moment that convinced Henry to build his own periscope came on October 5, when he watched German snipers kill 3 American soldiers in less than 10 minutes, picking them off one by one as they tried to use standard periscopes to observe enemy positions. The German snipers were positioned in treetop hides over 600 yards away, invisible to American observers using regulation equipment but perfectly positioned to target any American who exposed himself for observation. The standard periscope simply couldn't provide the magnification and clarity needed to spot these distant threats. Henry realized that the fundamental problem wasn't with American courage or tactics, but with American equipment. The soldiers were doing their jobs correctly, but their tools weren't adequate for the mission requirements. They needed better optical equipment, and if the army couldn't provide it, Henry would have to create it himself. That evening, Henry began scavenging materials from the battlefield debris that littered the Hürtgen forest. Destroyed vehicles, abandoned equipment, and damaged buildings provided a treasure trove of optical components that Henry could adapt for his purposes. He collected mirrors from vehicle periscopes and rear-view systems, lenses from binoculars and rifle scopes, and metal tubing from various mechanical components. His goal was to create a periscope that could provide clear observation at distances over 1,000 yards while maintaining the concealment characteristics that kept observers safe from enemy fire. The design Henry developed was based on principles his father had taught him about telescope construction, but adapted for the specific requirements of battlefield observation. The device would use multiple mirrors and lenses to extend and clarify the image, while maintaining a low profile that wouldn't reveal the observer's position. His fellow soldiers were skeptical about Henry's project. Several of them joked that he was building a toy telescope that would be useless for real military applications. Others worried that Henry was wasting time on a hobby project when he should be focusing on immediate survival concerns. But Henry understood something that his critics didn't. In the Hürtgen forest, better observation capabilities weren't a luxury, they were a matter of life and death for every American soldier in the area. The engineering breakthrough that defied expectations. Henry's periscope design was both simpler and more sophisticated than the standard military equipment it was intended to replace. Instead of relying on mass production and standardized components, Henry's device was custom-built for optimal performance under the specific conditions of forest warfare. The key innovation was Henry's use of multiple mirror systems that allowed him to create a periscope with an extended vertical reach and enhanced light-gathering capability. By positioning mirrors at carefully calculated angles, Henry could observe over tall obstacles while maintaining concealment below ground level. The lens system was equally innovative. Henry had salvaged high-quality optical glass from German binoculars and rifle scopes, combining these components with American lenses to create a magnification system that could resolve details at distances over 1,500 yards. But perhaps most importantly, Henry had designed his periscope to work effectively under the low-light and high-moisture conditions that characterized the Hürtgen forest. The device included light-gathering features and anti-fogging measures that maintained clear vision even when standard equipment became useless due to environmental conditions. The construction process required skills that Henry had learned from his father and refined through years of building and repairing optical equipment. He hand-ground lenses to achieve precise focal lengths, aligned mirrors to tolerances measured in fractions of degrees, and sealed the entire system to prevent moisture infiltration. The final device was larger and more complex than standard military periscopes, but it was also vastly more capable. Henry's periscope could provide clear observation at distances that exceeded the capability of most military binoculars, while maintaining the concealment characteristics essential for survival in sniper-infested terrain. The first test of Henry's completed periscope exceeded even his own expectations. From his concealed position, he could clearly observe German positions that had been invisible to American forces for weeks. He could count individual soldiers, identify weapons and equipment, and track movements with a precision that was impossible using standard observation methods. Most importantly, Henry could see German sniper positions that had been killing American soldiers without being detected. For the first time since entering the Hürtgen forest, American forces had an observation capability that matched or exceeded German surveillance technology. The discovery that changed the battlefield. Henry's first major success with his custom periscope came on October 10, when he detected a German infantry company preparing for a surprise attack on American positions. The German forces were assembling in forest clearings over 1,200 yards from American lines, far beyond the detection range of standard observation equipment. Using his enhanced periscope, Henry was able to count approximately 120 German soldiers, identify their weapons and equipment, and track their movements as they prepared for what appeared to be a coordinated assault on American defensive positions scheduled for dawn. Henry immediately reported his observations to his company commander, Captain Robert Miller, but the report was initially met with skepticism. The German positions Henry described were beyond the range where previous American observations had detected enemy activity, and the scale of the German force seemed larger than intelligence estimates had suggested. Captain Miller's first instinct was to doubt Henry's report, since it contradicted existing intelligence and seemed to be based on observation capabilities that exceeded what American equipment should have been able to achieve. But Henry's reputation for accurate observation and his detailed description of German positions convinced Miller to take the report seriously. Based on Henry's intelligence, American artillery units prepared defensive fires on the German assembly areas, while infantry positions were reinforced to meet the expected attack. The preparation was completed just hours before the German assault began, exactly as Henry had predicted. The results were devastating for the German forces. American artillery caught the German infantry company in the open during their approach march, inflicting heavy casualties and disrupting their attack plan. The coordinated assault that should have achieved surprise and overwhelmed American positions instead became a costly failure that forced German commanders to reconsider their tactical approaches. More importantly for Henry's innovation, the success demonstrated that his custom periscope could provide intelligence capabilities that gave American forces a significant tactical advantage. His device had detected enemy activity that would have remained invisible to standard equipment, providing the advance warning that allowed American forces to prepare an effective defense. Word of Henry's observation success spread quickly through the 28th Infantry Division, attracting attention from intelligence officers and tactical commanders who recognized the potential value of enhanced observation capabilities in forest warfare. The innovation that multiplied effectiveness. The success of Henry's periscope led to requests from other units for similar devices, but Henry quickly realized that building custom periscopes for every observer would require more time and materials than were available under combat conditions. His solution was to develop simplified construction techniques that allowed other soldiers to build their own enhanced periscopes using scavenged materials and basic tools. Henry created instruction guides that explained the optical principles behind his design and provided step-by-step procedures for assembling effective observation devices from battlefield debris. The key insight was that enhanced observation didn't require perfect optics or precision manufacturing, it required understanding how to combine available materials to achieve specific performance objectives. Henry's techniques could be adapted to different materials and conditions, allowing soldiers to create observation devices that were optimized for their particular operational requirements. Within 2 weeks, over 30 soldiers in the 28th Infantry Division had built their own enhanced periscopes using Henry's techniques. The devices varied in design and capability depending on available materials and individual skill levels, but all of them provided significant improvements over standard military equipment. The proliferation of enhanced observation capabilities began to change the tactical balance in the Hürtgen forest. American forces could now detect German movements at distances that had previously been impossible, allowing them to prepare defenses and call in artillery strikes before German attacks could achieve surprise. German commanders began to notice that their tactical advantages were eroding as American forces seemed to anticipate German movements and respond more quickly to emerging threats. Intercepted German communications revealed frustration and confusion about American intelligence capabilities that seemed to exceed what German forces had experienced in previous battles. But the most important impact was on American casualties. Units equipped with enhanced observation devices experienced significantly lower casualty rates than units using only standard equipment, as early detection of German threats allowed American forces to take protective measures before coming under fire. Henry's innovation had proven that individual creativity and practical engineering could provide capabilities that formal military research and development had failed to deliver, achieving results that saved lives and improved mission effectiveness under the most challenging combat conditions. The recognition that validated innovation. The success of Henry's periscope innovations attracted attention from higher military commands, including intelligence specialists and equipment development officers who were interested in understanding how an individual soldier had achieved observation capabilities that exceeded official military equipment. Major William Chen, an intelligence officer with the V Corps, was dispatched to study Henry's techniques and assess their potential for wider application throughout American forces in Europe. Major Chen had a background in optical engineering and had been involved in developing some of the standard periscope designs that Henry's innovations had surpassed. Chen's initial reaction to Henry's device was amazement at the sophistication of the optical design and the quality of the results achieved using scavenged materials and improvised construction techniques. Private Thompson, this device would be impressive if it had been built in a fully equipped optical laboratory. The fact that you built it in a foxhole using battlefield debris is extraordinary. Henry's response was characteristically modest. "Sir, I just used what my father taught me about telescopes and adapted it for what we needed here. The principles aren't complicated if you understand how light and lenses work together." Chen spent several days testing Henry's periscope and observing his construction techniques. The testing revealed that Henry's device not only matched the performance of expensive military optical equipment but actually exceeded it in several important categories. The enhanced light-gathering capability allowed effective observation under low-light conditions when standard equipment became useless. The superior magnification and resolution provided clear identification of targets at distances that exceeded the range of most military binoculars. The anti-fogging and moisture resistance maintained clear vision under environmental conditions that degraded the performance of regulation equipment. Perhaps most importantly, Henry's techniques could be taught to other soldiers and adapted to different materials and requirements, making enhanced observation capabilities available to units throughout the Army rather than limiting them to specialized personnel with expensive equipment. Chen's report to V Corps headquarters recommended immediate implementation of Henry's techniques throughout American forces, with provisions for training programs that would teach soldiers how to build and maintain their own enhanced observation devices. The training that spread the advantage. Henry was temporarily assigned to the Army Intelligence Training Center in Paris, where he was tasked with developing standardized procedures for teaching enhanced periscope construction to observation specialists throughout the European theater. The assignment presented unique challenges, since Henry's techniques were based on intuitive understanding of optical principles and practical experience with improvised construction methods rather than formal engineering training. The solution was to create training programs that combined Henry's practical techniques with theoretical explanations that helped other soldiers understand the principles behind his innovations. The training emphasized understanding the relationship between optical components and observation requirements, teaching students how to analyze available materials and adapt construction techniques to achieve specific performance objectives. Students learned to evaluate lenses, mirrors, and other optical components for their suitability for different applications, and to modify their designs based on available materials and operational requirements. Henry also taught advanced techniques for optimizing observation devices for specific environmental conditions and tactical situations. Students learned to adjust their devices for different lighting conditions, weather patterns, and terrain characteristics, creating observation capabilities that were optimized for their particular operational environments. The program produced observation specialists who could not only build their own enhanced devices but also teach the techniques to other soldiers in their units, spreading Henry's innovations throughout American forces in Europe and eventually to other theaters of operation. But perhaps most importantly, the training programs emphasized the principle that effective observation required understanding the relationship between human vision, optical enhancement, and tactical requirements. Students learned to think like enemy forces, understanding how opponents would position themselves and move in ways that could be detected by enhanced observation techniques. The legacy that outlasted the war. Henry Thompson's periscope innovations continued to influence military observation techniques long after the end of World War II. His principles and methods were incorporated into official military doctrine and became standard elements of reconnaissance training for subsequent conflicts. The fundamental insights Henry had developed, that effective observation required adapting optical principles to specific operational requirements, that enhanced capabilities could be achieved using improvised materials and construction techniques, and that individual innovation could provide advantages that formal research and development had missed, became core principles of modern military reconnaissance. His techniques were adapted for use in different environments and with different equipment, from jungle operations in Vietnam to desert warfare in Iraq. The basic approach of using available materials to create mission-specific observation devices became standard practice for special operations units and reconnaissance forces. During the Cold War, Henry's innovations influenced the development of observation equipment for both military and intelligence applications, with particular emphasis on techniques that could be implemented quickly and adapted to changing operational requirements. The principles Henry had pioneered also influenced civilian applications of optical technology, from wildlife observation to surveillance and security systems. His understanding of how optical enhancement could extend human vision proved valuable for any application that required effective long-distance observation. After the war, Henry returned to West Virginia where he established a successful optical equipment business that served both civilian and military customers. He specialized in custom optical devices for surveying, astronomy, and wildlife observation, using the skills he had developed during the war to create high-performance equipment for specialized applications. Henry received the Silver Star for his contributions to Allied success in the Hürtgen forest, but his most important recognition came from the soldiers whose lives his innovations had saved by providing them with the observation capabilities they needed to detect and respond to enemy threats. The soldiers who had once mocked the toy telescope came to understand that Henry Thompson had achieved something that millions of dollars in research and development had failed to accomplish. He had created observation technology that actually worked under combat conditions and provided the tactical advantages that American forces needed to survive and succeed. The human dimension of technical innovation. Behind the technical achievements and military applications of Henry's Periscope innovations were human stories that illustrated the profound impact of individual creativity and determination on the lives of fellow soldiers and the success of military operations. The enhanced observation capabilities that Henry's devices provided allowed American forces to detect German threats before they could launch effective attacks, saving countless lives that would have been lost to surprise assaults and sniper fire. Tank crews, infantry units, and artillery observers all benefited from the early warning and detailed intelligence that Henry's innovations made possible. The psychological impact on American soldiers was equally important. Troops who had felt vulnerable and blind in the dense Hürtgen forest gained confidence and effectiveness when they knew they had observation capabilities that could detect enemy movements before they became immediate threats. This confidence translated into more aggressive and effective operations, as American forces were able to conduct patrols and reconnaissance missions in areas that had previously been too dangerous due to limited observation capabilities and German sniper threats. Henry's relationship with the soldiers he supported was characterized by mutual respect and professional dedication. Soldiers appreciated Henry's commitment to developing techniques that actually worked under combat conditions, rather than simply following regulations that might not address real operational needs. For Henry, the most important measure of success was not technical validation or official recognition, but the knowledge that his work was keeping American soldiers alive and helping them complete their mission successfully. The personal satisfaction Henry gained from solving practical problems with creative solutions motivated him to continue refining and improving his techniques throughout the war. This commitment to continuous improvement and practical effectiveness became a model for other military innovators who understood that the best solutions often came from understanding real-world problems and developing creative approaches to solving them using available resources and practical knowledge. The relationship between individual initiative and collective success that Henry's story illustrated became an important example of how military effectiveness could be enhanced through the creativity and determination of individual soldiers who were willing to challenge conventional approaches and develop better solutions. The enduring principles of practical optics. The broader significance of Henry Thompson's story extends beyond military observation to fundamental questions about innovation, problem-solving, and the relationship between theoretical knowledge and practical application. Henry had demonstrated that effective solutions often required combining scientific principles with hands-on experience and creative adaptation to specific requirements. His success was based on understanding that laboratory-designed equipment and real-world applications could produce very different results, and that effective techniques needed to be optimized for actual operating conditions rather than theoretical scenarios. Henry's approach required deep understanding of optical principles, but it also required practical skills in construction, materials evaluation, and environmental adaptation. The principles Henry applied, careful analysis of operational requirements, creative use of available materials, and continuous refinement based on practical results, proved relevant to many fields beyond military applications. His techniques demonstrated that sophisticated capabilities could be achieved without expensive equipment or formal manufacturing facilities, provided that the designer understood the underlying principles and was willing to experiment with innovative approaches. Henry's story illustrated the importance of combining different types of knowledge and experience when addressing complex problems. His background in astronomy and telescope construction provided insights that formal military training had missed, demonstrating that innovation often comes from bringing diverse perspectives and skills to bear on challenging problems. Perhaps most importantly, Henry Williams had shown that individual initiative and creative thinking could achieve results that large-scale research and development programs had failed to accomplish, provided that the individual understood the problem thoroughly and was willing to experiment with unconventional solutions using whatever resources were available. So here's the question Henry's story poses: in your own field, what limitations are you accepting that might be overcome through creative application of fundamental principles and innovative use of available resources? What knowledge and skills from other areas of your experience might provide insights that conventional approaches have overlooked? And do you have the confidence to experiment with unconventional solutions when conventional equipment and methods aren't providing the results you need? Henry Thompson proved that sometimes the most effective innovations come not from research laboratories and engineering departments, but from practical people who understand problems intimately and are willing to apply fundamental principles in creative ways to achieve specific objectives using whatever materials and knowledge are available to them.